Bioengineering is kind of like that. It's about coming up with ways to put these cells, fundamental units, together as functional tissues, organs, biodevices, and then figure out a smart way to deliver, into our body, and at the same time, in hope that it will form or integrate with our existing networks. What gets talked about a lot these days, all over the world, stem cell and regenerative medicine. Stem cell is simply a collective general term. So there are a billion different types. The most potent, proven stem cell type is the so-called pluripotent stem cell. One is that it's serving as an unlimited factory. So which is like, as far as there is demand, they provide you with the supply. I think that's extremely important. And secondly, they can they can basically become all cell types of the body, meaning that you need a light bulb, it's always there for you. Not only a light bulb, but everything that you need at home. So productivity, the flexibility are just remarkable. It's something we've never seen before in the history of medicine. Technologies that we are talking about, and I was going to say that these are no longer at the conceptual stage. And what we have to deal with to some extent is like we have to think about raw materials, mass production, quality control, and engineering plan.
How to connect big data with the human body capacity? How to connect big data with life? That's exactly the answers my field, genomics, would like to answer. The secret is inside that sequence of ATCG. Just the arrangements, it takes a long amount of 13 years and a big amount of money, about $3 billion to make the first sequence map of the human genome. But no doubt, to know the sequence is the first step towards knowing ourselves. The first step to know why this strain of rice is much higher, has a higher yield than the other, and this medicine is much better for this person than another person. Why we pick up innovation in Asian for this subject or this panel discussion? The first, concerning sequencing technology, Professor Rui Wu was the first pioneer in determining the 21 BP of a short fragment sequence much earlier than Frederick Sanger. The first idea about automatic sequencing was given by Professor Wada. The sister project after the Human Genome Project, so-called the International HapMap Project, that amount of data is at least 5 times that of the whole data for the first human genome sequence. And then back to me, myself, I'm chairman of BGI. Please don't ask what BGI means, but anyway, it is widely acknowledged to be the biggest sequencing center in the world. Asians have their advantages in this important area.
Year 2000, Tony Blair and Bill Clinton has announced to the world that a human genome has been sequenced for the first time in history. And at that time, it cost about $3 billion, and it takes many scientists from 45 countries and 12 years just to sequence one human genome. Now, over the last, it was far away from being practically used in daily life. But over the last 10, 15 years, the cost has been reduced significantly. Basically, you can run sequencing a human genome for a few $1,000s in a few days. The rapid reduction of this cost, plus the very quick accumulation of the human genomic data over the last few years, has been triggering a wide variety of new applications that has never been thought of before. For example, in oncology, you'll be able to use sequencing to select a better therapies, prenatal screening for Down syndrome, Edwards syndrome. They are now can be done with non-invasive procedures by sequencing. Just drawing the blood from mother with 10 weeks into pregnancy. This is so-called coming up with the optoelectronic single molecule sequencing. And our goal is to make the sequencing a daily routine of healthcare. And we want a doctor to be able to run a wide variety of DNA testing at a very affordable cost. I can foresee that in the future, the application will be in many, many different areas, even in forensic, in biosecurity, in agricultural, food, environmental, bioenergy, let alone the healthcare. And so that's a very mega opportunities.
Okay. You returned from the States some years ago, and then do you think Asia is competitive in this area?
This is a big field that we are talking about. There's enough room for everybody to do very, very well. So instead of competing, I would tend to think about collaboration and how to cover each other's weaknesses to make it a win-win-win-win situation.
You don't have to be the number one, but you have to be unique. When you are unique, then you are number one. So you just look for how can you be differentiated with others.
I'm wondering about your opinion on this kind of 3D printing of human organs and tissues.
So it's not about the challenge, the technical challenges associated with printing the scaffold, but more about printing the cells on the scaffold as well. So I think in the near future, this is going to be challenging, but you never know about science. In the very near future, we're going to be seeing banks of bioorgans, hearts, pancreases, livers, etc., that are personalized to some extent.
Whether we should change our genes to make us even better. No, at least at this stage, because we don't know our genes so much. If you change it, it would be more difficult to change it back.
Human cloning has been internationally banned. It's illegal. It's unethical. Nobody, as far as I know of, is doing it. So, but there are some hazy boundaries as well, meaning that it really depends on where you are, what your cultural background is, what your religious beliefs are. We all note about in vitro fertilization tests to baby. So in the 70s, when it first came along, people were basically killing each other because of that, and now we have accepted this as a medical option. So whenever major technologies come along, it's reasonable to expect, political debates and ethical debates, etc. But then as people get to accept the technologies, we change. So they change not only the way we live, but they also change the way we think.
Is any Asian innovation? Because there'll be reporter out there reporting this.
I can give you 4 examples. Xiaomi, the first one. Tencent in Shenzhen. Huawei in Shenzhen. And then BGI in Shenzhen. They have provided much more genome sequences than Harvard University, than the whole amount of NIH.
We are looking for very simple, easy sequencings that for small things. And that is an entirely new direction for innovation in using how to use sequencing. We're not changing any genes.
Our technologies are global, and there is no reason for us just to limit our thoughts and development regionally. But even with that said, being in Asia, this part of the world, there are advantages. There are Asian diseases. There are diseases, conditions that are more prevalent among Asians. And also considering genetic diversity, Northern Chinese are different from Southern Chinese. Chinese are different from Caucasians. I think there are a lot of possibilities for us to personalize, stem cell-based therapies. And that's the future.